There are four ways of drawing organic structures. The most important way is this one right here, that's called line diagram, or we're going to call it skeletal formulas or skeletal structures. I'm going to refer to them as skeletal structures. And the reason why they're most important, we're going to learn about them, is because they're the most convenient. And you're going to learn them really quick, and you'll see why. There's less you have to remember, and there's less you have to actually draw. Second one, probably more used, is also used, is structural formulas. Condensed formulas are also present. Now these you won't see anymore. So let's begin with condensed formulas, because these, we already talked about them in Lewis structures and structural formulas, but the main two we need to learn today is condensed and skeletal structures. Let's begin. Condensed structures have rules for drawing them. So let's start with number one. It says all of the atoms are drawn in, but the 2 electron bond lines are generally omitted. So as I've shown you when we drew the Lewis structure, I did not show the bonds, simply again because they take time and they're implied. Atoms are drawn next to the atoms to which they are bonded. So in this case, you have the C attached to 3 H's and of course to the C next to it. Parentheses are used around similar groups bonded to the same atom. And lone pairs are not shown, they're omitted. So let's actually show you the condensed formula for this structure right here. All right, so start from the left with C. You always start with C. So this C right here, first carbon, let's say, has 3 H's on it. Okay, what comes next? You have a C with 2 H's. Here it is. So I'm going to call this 1, that's 2. Here's 1, that's 2. Then comes a C. And obviously that's an O. You also have a C with 2 H's. So let's number them. This is 3 and this is 4. It's 3, that's 4. And we have N with 2 H's. There it is. So CH2, CH3, CH2, CO, CH2, NH2. That would be your condensed formula. Now let's look at a more involved one. Let's begin. C and 3 H's, CH3. Took care of that one. Next, we have a C. You always draw the C and then the H. Here's this H. And then there's a Cl. I have to include the Cl. Next would be also a C with an H and a Cl, so it's kind of like a repeat. So I'm going to number them 1, 2, 3, 1, 2, 3. Careful not to number the chlorines. And then we have a C, and they said something about parentheses. Okay. If you go back up here, it says parentheses are used around similar groups bonded to the same atom. Okay. So if you look here, there's a CH3. There's two of them. Here's a CH3, and there's another CH3. Now, we can't just list, if you list CH3, CH3, whoever is reading may think that there are what? There are two CH3s attached to each other. So what you do in this case is the following. Is you open parentheses, CH3, close it, 2. It's kind of like Gen Chem when you had to put the polyatomic when you had more than one, you had to put it in parentheses and of course include the number afterwards. So again, this is why I said CH3, CH3, there's two of them and I put them in parentheses. So that's our number 4. Continue. CHBr, that's a Br right there. CH2, CH2. Let me keep the numbering so you can follow here. So you have 5, you have 6, you have 7, that's 5, 6, and 7. Okay. Next, we have a C, H, and now again, we have a CH3. So since it's attached to it, the same group, we have to include it again in parentheses, like that. Otherwise, if you include it next to it, again, we would think it's the next one attached. So be very careful. The CH3s generally are going to go in parentheses. And then next is going to be a CH2, and then you have an OH. So let me keep the numbering. This is our 8, and this is our 9. Here's 8, and here's 9. So take a minute, think about it, and please prepare questions for the next time we meet.